What's up, mathletes? Dr. Math here, just making sure that you don't get stumped by these logs. All right, mathletes, so let's go ahead and let's talk. Let's talk about this equivalency property of logs. All right, so here's the big idea. All right, the big idea is when you have one logarithm, and notice they have to have the same base as long as that base is not 1. So when you have one log on each side, then we say that the arguments, right? Whatever's in parentheses here, those arguments must be equal. That's what this property does. And it's going to save us a lot of time and money because we all know that time equals money. All right. So this first example that we're going to go through is quite nice because it's already picture perfect, like some of us. All right. So since we have the log, and notice the bases are the same. So since these bases are the same, what this property is telling us is that these arguments inside here are equal. So let's go ahead and use that. All right, so let me get my pen. Let me get my glasses because I don't know what the heck I was pointing at. And so what I'm going to do is I'm going to highlight, and what we know is that those two arguments right there are the same. So we end up with 3x minus 4. That first argument must be equal to the argument on the other side. And this, once you get to this statement, then this becomes a whole new problem, right? This becomes much easier than what we were given initially. And you have to ask yourself, okay, here, is this a linear equation? Is this a quadratic? Is it rational? Because from here on till you finish, right, that's going to determine of what do I do next. All right, so always have that in mind as you're going through these problems. This one's easy because this is just a linear equation. So let's go ahead and solve. So we'll subtract x from both sides. And so we are left with 2x minus 4 equaling 2. Let's go ahead and, let's just be a little weird. Let's just divide everything by 2. I know we should add 4, but we want to be a little different here, right? We want to be a little different.
Your boy's different.
The steps don't matter, so I want you to exercise your creativity. So if I take half of everything, I'm left with x minus 2, and that's equal to 1. So let's go ahead and add 2. And so right away, now we notice, oh, now the x is by itself. I don't have to divide at the end. So here we have x equals 3. But always remember, we need to plug it back into the original. And what you're really checking for is to make sure that when you plug in this number into the argument, this argument better be a positive number. And when you check it, it does. All right, so here's our first example of how to solve logarithmic equations using the equivalence property. All right, so example 2 here, very similar to the first example we saw, because you have one log on each side and they have the same base. So since they have the same base, we can use that equivalence property that we just talked about, right? And so what that tells us is that these arguments, right, are also equal. So let's go ahead and set this equation up, this next step. So we're left with x squared plus 7, and that equals negative x plus 13. So now what I want you to notice is, oh good, my dog notices too. What I want you to notice is that this is a quadratic equation. So write that down, quadratic equation. And because this is a quadratic equation, right, we must set one side equal to 0. All right, so we're gonna move everything from one side and throw it on the other side, right? Because you wanna set this equation equal to 0. Because it's quadratic. So let's go ahead and let's move all these terms. Let's move them to our left hand side. Oops. Plus x and minus 13. All right, so we moved all our x. So notice on our left hand side, these cancel and we're everything's equal to 0, right? So one side is equal to 0, just like we want. And on our left-hand side here, we're left with x squared plus x minus 6 once we combine our like terms. All right. So here we have a couple of options. You have a lot of options, but let's just stick to 2. Number 1, what you're going to hope and pray for is that you could factor this mother sucker. All right. Option 2 is if you can't factor, you could always use the quadratic formula. All right. So here, let's try to factor this. All right. So let's factor like it's 1999. And if you need help factoring, I have a link to one of my videos down below. All right. So we're left with x times x. And here we need two numbers that multiply to give me -6, and those same two numbers got to add up to +1. So we know that's going to be +3 and -2. So these are our mother factors, right? So now what do we do with each one of those factors? Well, we should recall that now we set each one of those using our zero product property equal to 0. So we set each one of these factors, right? We set them equal to 0. And now we solve. So let's go ahead and subtract 3. No, I don't want that. Let's subtract 3 from both sides. And we get x equals -3. Possibly, right? Because I still got to check this at the end. And then I'll add 2 to both sides in this other equation, and we get x equals 2. Possibly. Because again, what I need to do is I need to throw these back into the original equation to make sure that these check out. All right, so what I'll do here is let me show you how this check works. So let me go ahead and grab everything. So I'm going to grab that 2, this one right here. Let me highlight it so you know what I'm talking about. I'm going to grab this and I'm going to plug it into the original, right? So the original function said log base 7 and x squared. So it's going to be 2 squared plus 7 equals log, let me move this out of the way, base 7 of -2 plus 13. All right, so let's go ahead and evaluate both sides. So we get log base 7, and here we're left with 2 squared, so 4 plus 7. So we get 11 on one side. And on our right-hand side, we got -2 plus 13. And so we get log base 7, and we also get of 11. So notice this one checks out. So this 2 checks out. Now let's plug in the -3 and let's see if it checks out. But again, let's say this was log base 7 of 13 and this was log base 7 of -13. If these are not the same, then this would not have checked out. Okay, and plus if we're talking about logs, we know the argument has to be positive. So that's another way of noticing if it doesn't work. All right, let's plug this one in too to check to see if it works out. So let's go ahead and plug it in everywhere we see x. So we got log base 7 of -3 squared. Be good users of those parentheses. Plus 7, and we got equals to log base 7 of -3 plus 13. All right, so let's go ahead and evaluate each side. So we end up with log base 7 of 9 plus 7. All right, so that's what we have on our left-hand side. And on our right-hand side, we have log base 7 of +3 plus 13. All right, so when we simplify both sides, what we're hoping for, if this is an answer, is the same statement on each side. So on our left-hand side, we have log base 7 of 16. And on our right-hand side, we have log base 7 of 16. So they are equal. So x equals -3 is, in fact, our second solution. So let's write this in our solution set. So our first answer was -3. And our second answer, I believe it was, let me go back and cheat for a second. I think it was 2, our second answer. All right, so there's our second example, and something bad happened to Toby. But let's move on to example number 3. All right, for example 3 here, notice we have 1, 2, 3 logs. And in this case, all 3 are natural logs, right? They're natural. So we might think, well, how can I use the equivalent statement here, the equivalency property, right? Because I don't have 1 log on each side. But my question to you is, but can you have 1 log on each side? All right, so what I want us to look at is, notice I have the natural log of something minus the natural log of something else. So because we have a subtraction, don't forget your properties. All right, so let's rewrite this. So what we really have is a natural log of x minus 4, and we're going to use the quotient property of natural logs. And what that says is you take that first argument, let me highlight it here for you, of the x plus 6, right? And that's what goes in our numerator. And in our denominator, we take that second argument. And so that x goes in the denominator. And now you see that you have 1 log on each side of our equation. So because now you have 1 natural log, right? Because they have the same base, it's log base e, on each side, what happens is now we're allowed to set the arguments. Let me write this in black. Now we're allowed to set those arguments equal to each other. And so the first example we saw when we got to this step, we saw a linear equation. The second step, when we use that property, we were left with a quadratic. And now, notice, we have a fraction. So now we are left with a rational. Rational just means we have a fraction. A rational equation. A rational equation. And one way to solve rational equations here is I could find the LCD, which is x, and I'm going to blast every single one of these terms by the LCD to get rid of that fraction. So let's do that. So let me go ahead and do some math magic for you. Let me copy this. And what we said is we're going to find the LCD, which in this case is x, our least common denominator, and we're going to multiply every single term by x. And what's going to happen, the whole point of that is now this x and this x are going to cancel, and we no longer have fractions. You see what I did there? All right, so we're left with x squared minus 4x, and that's equal to x plus 6. So wait a minute. We started with the log, right? A logarithmic equation. Then we went to a rational equation. And now this rational equation turned into a quadratic equation. We said anytime we had a quadratic equation, we set one side equal to 0. Right? So let's be consistent. Let's go ahead and subtract x from both sides, subtract 6 from both sides, and let's combine our like terms. So one side is equal to 0, just like we want. And ooh, important note, don't forget to subscribe. Don't forget to smash that like button. Man, what am I thinking? My producers are gonna kill me. They're evil. They're evil. Alright, so don't forget to combine your like terms here. So we get minus 5x and then minus 6. Alright. So again, we said this is a quadratic, so you have 2 options. Hopefully you could factor. If not, we can use a quadratic formula. But I think we'll be able to factor this. Again, I got a video right here, in case you need help factoring. All right, so we got x times x, and then our 2 factors, one is going to be minus 6, and the other is going to be positive 1, because when we multiply negative 6 times positive 1, right, we end up with -6, but when you add these two, you end up with that -5 right there. Cool, so let's move everything up. And now we're gonna go ahead and set each one of these factors equal to 0. So on this first one, we'll add 6 to both sides. So one possible answer is x equals 6. And our second equation here, we have x equals -1 as a possible answer. So let's do a little recap. We're not done, but I want to recap. Oh, let me group everything together. All right, so notice we started with a logarithmic equation. Then it turned into a rational equation. Then it turned into a quadratic equation. And now it's two linear equations, right? So now we have to check our work, right? After you did all that work, you got to check your work. All right, so we are on step 237. All right, so what we do is we're going to plug in 6 first, one at a time. So first I'll plug in this 6 into our original equation. Let me bring it down just in case you forgot. So I'm going to plug in the 6 right there, and right there. But I'm going to give you a little shortcut here. Right, here's our shortcut. The 6 is going to work. But that -1, right, check out this -1. When I plug in the -1 right here, this is going to leave me with a negative argument. That's not possible. Or I could plug it in right here, and I get natural log of -1. I'm going to get a domain error. That's not possible. So right off the bat, I don't even have to plug in that -1. I know that this is not going to work out.
Get that cone out of my face!
So my only solution here is going to be +6. But you go ahead and plug it in just to verify. All right, folks. So hopefully this video helped you out. And don't forget to do us the favor and give us a like and smash that subscribe button. We'll see you guys in the next video. Peace.